All right, let's jump right into some huge news coming out of the world of theoretical physics. I mean, this is a big one. Something that scientists believed was totally impossible. Well, it turns out it's not.
I want you to think about a rule in science. You know, one of those core principles that's in every single textbook, the kind of thing they teach every new physicist on day one. For decades, a rule just like that in particle physics was considered absolutely unshakable. Well, guess what? It just got broken.
And here's the part that makes this story just mind-blowing. The discovery? It wasn't made by a human on their own. Nope, it was a partnership, a really incredible collaboration with an AI.
Okay, so let's get into the details. What did this human AI team actually find? What is it exactly that's just been upended in how we understand the universe? So let's be clear, this is not some small tweak. We're talking about gluons here. These are the tiny particles that literally glue everything together, carrying the strong nuclear force that holds atoms together. And for as long as we can remember, the official story was that a very specific kind of interaction between them just couldn't happen. The odds were zero. But this new research shows that, hey, if you get the conditions just right, the impossible actually becomes possible.
All right, to really get why this is such a game changer, we've got to dive into the old textbook rule that just got, well, completely rewritten.
You know, when physicists smash particles together in those giant colliders, they need a way to figure out what's going to happen, right? Well, the tool for that is something called the scattering amplitude. Think of it as just a fancy math formula that predicts the chances of a certain outcome. You know, like two particles hitting each other and flying off in a specific direction. Okay, now stick with me. Particles like gluons, which have no mass, have this property called helicity. It sounds complex, but it's really just about their spin. The best way to picture it is a football spinning through the air. It can spin one way, or it can spin the other way relative to its flight path. And that's it. We just call those positive and negative helicity.
And this right here, this is the heart of the discovery. The old rule, the one in all the books, said that if you get a bunch of gluons interacting and only one of them has that negative spin while all the others have a positive spin, that interaction just can't happen. The probability is zero, end of story. But what this new research found is a loophole, a tiny exception. It turns out that under a very, very specific alignment, something called the half-colinear regime, the probability is not zero. It's kind of like discovering a secret, perfectly aligned tunnel that lets a ball pass straight through a wall you were absolutely sure was solid.
Now, to be super clear here, this doesn't mean we have to throw out all the old physics textbooks. Not at all. It just means scientists have found a new, very special case where the old rules don't quite fit. It was a blind spot, a really specific situation that everyone had just missed, until now.
But honestly, what might be even cooler than the what is the how. I mean, how they figured this out. This wasn't some lone genius scribbling on a blackboard and yelling Eureka. This was something new, a really powerful team-up between human scientists and an AI. So check this out. Here's how it all went down. First, the human physicists did the hard nitty-gritty math by hand. And the equations they got were just unbelievably complicated. So they fed these monster equations to an AI, GPT 5.2 Pro. The AI's first job was just to simplify them, which it did, like, a lot. But then, and this is the amazing part, it actually spotted a hidden pattern in those simplified results and came up with a universal formula that should work for all similar cases. To lock it all down, another AI model then worked for 12 straight hours to cook up a formal proof. And of course, the human experts were there at the end to double-check everything. It's this perfect dance of human intuition guiding the AI's raw analytical power.
So the big question is, what does all this mean? Is this just a cool one-time thing? Or are we standing on the edge of a whole new way of doing science?
Well, the ripple effects are already starting. This one discovery has blown the doors wide open for a ton of new research questions. In fact, the team is already using this same AI method to look at gravitons, the particles we think are responsible for gravity. So it's not just about one result. This is a whole new playbook, a new template for how to make scientific breakthroughs.
And this gets at something really fundamental. A top physicist, Nima Arkani-Hamed, has talked about this before. He says that so often in physics, you start with these incredibly messy, complicated expressions, but they boil down to something really simple. And those simple formulas? They're like treasure maps pointing us toward deep, new truths about the universe. And that's exactly what the AI did here. It found the beautiful, simple truth hidden inside all that mathematical chaos.
Another expert, Professor Nathaniel Craig from UC Santa Barbara, put it perfectly. He said this whole thing feels like
a glimpse into the future of AI-assisted science. He's saying this paper isn't just about gluons. It's a blueprint for the future. It shows how we can combine the best of human expertise with the incredible power of these AIs to see patterns and reason through problems we couldn't solve before.
So it really leaves you wondering, right? If this is what a human-AI partnership can do today, literally rewrite a rule of physics, what are they going to find tomorrow? We could be right at the beginning of a brand new era of discovery, where the next huge breakthrough is just waiting for the right team of humans and AI to find it.